Hi everyone, this is Amy from the Helms Academy, and today we're going to be going over our Math Roundtable recap from December 10th, 2020, when we talked about some mental math tips and tricks that you'll be able to use to increase your own math skills and make you faster at solving some of those problems for your GED, HiSET, or TASC test. So our first skill today is talking about multiplying by nines. So you can see we have the full length of all the different multiples of 9 up to 9 times 9 on the left side of the screen. Now we're going to fill those in. So 9 times 1 is 9, 9 times 2 is 18, and so on. You can see the list there. Now there are a couple things I want to point out to give you some tricks to work with on how to multiply these numbers. So if you're multiplying by 9, one thing to remember is that the answer that you get, if you were to take apart the two numbers, they would add up to 9. So look at this. 9 times 2 is 18, and 18 is a 1 and an 8, which together add up to 9. 9 times 3 is 27, which is a 2 and a 7. Put those together, they add up to 9. Same thing with 36, 45. 3 plus 6 is 9, 4 plus 5 is 9, and so on. Now, you might also notice that if you look right where we have that 45 and 54, that there's an interesting pattern. It's that the numbers become switched, right? So 4, 5, 5, 4. Go one up and one down. 9 times 4 is 36. 9 times 7 is 63. So 3 and 6 just swapped there. And you can do the same thing for 27 and 72, as well as 18 and 81. Another way to think about multiplying by nines is that each time you multiply, you get the tens number goes up and the ones place value goes down. So we have 1, 8, then the 1 becomes a 2 and the 8 becomes a 7. The 2 becomes a 3 and the 7 becomes a 6 as you move down that list. So there are a lot of interesting tricks with nines that make them a little bit easier to remember and more fun to work with. The other trick I want to point out is with your hands. So do me a favor, put your hands out in front of you like this so that you can see your fingers. Now, let's take 9 times 2 as an example. So if you have your hands in front of you, I want you to put down the second finger from the left that you see, just like you see on the screen here, the one that has an X on it. Okay, if you look at that then, and you look at how many fingers are left up on the left side and how many fingers are left up on the right side, you should see there's just one finger, just your pinky up on the left side, and there are 8 other fingers from both hands on the other side. So that means we have a 1 and an 8, so 9 times 2 is 18. This works with all of your fingers. So let's take a look at another one. What if we did 9 times 3? Well, put out your hands, put down the third finger that you see from the left, and just like you see on the screen there, now we have 2 fingers left on the left side of that finger that's down. And on the right side of the finger that's down, there are still 7 fingers left. So 9 times 3 is 27. So there's another trick for you if you're in a test. You'll obviously have a calculator on the HiSET test or the TASC or GED, but you'll also have your hands there. And that's another quick trick to be able to solve these things quickly and use your mental math skills. There's another trick for nines if we're talking about addition. So if you're adding 9 to a number, what you can do to kind of skip around that is to add 10 first and then just subtract away that one additional number that you added in. Let me show you an example. So if you had 9 plus 8, it may be easier to think of it instead of 9 plus 8 as 10 plus 8, right? I tend to add more easily if I see a 10 than I do a 9, because I know quickly that 10 plus 8 is 18. So if I were to use this strategy, I'm rounding my 9 up to 10. I get the number 18 there, and then I would just take 1 away from that, which is 17. To look at this in another context, you could also use it with other numbers. Like if we had 39 plus 28, well, I could do something similar. I could round my 39 up 1 number to 40, because 40 plus 28 is a lot easier to deal with. It's 40, 50, 60, and then 8 more, that's 68. And then I just take 1 away, which is 67. Now, here's another one to keep in mind. If you're working on your mental math, it's good to remember the doubles. So if you can memorize these doubles, 1 plus 1, 2 plus 2, and so on, that will put you one step ahead. But here's one more little piece. Once you have those doubles down and you remember what those are, it becomes a lot easier to do a whole bunch of other addition facts because you can do doubles plus 1. So for example, if I already know what 5 plus 5 is, then 5 plus 6 is easy because I'm just going to add one more to what 5 plus 5 was. So I would say, okay, I know 5 plus 5 is 10. That means that 5 plus 6 is 11. Same thing if I'm looking at 9 plus 8. Well, I know that 8 plus 8 is 16. And if I add one more for that 9, then that means it's going to be 17. So the facts become easier as we memorize some of the baseline pieces, like these doubles. Now, we can also use addition facts when adding bigger numbers. So, for example, if you know that 7 plus 8 equals 15, you'll also be able to do these additions in your head. For example, 70 plus 80, right? Very similar to 7 plus 8, but they're both amounts in tens, right? 7 is 7 ones, 8 is 8 ones, 70 is 7 tens, and 80 is 8 tens. So altogether then, that means we have 15 tens or 150. Same thing, if we had 700 plus 800, then it'd be 15 hundreds or 1,500. So similarly, what if we did this? If we had 2 plus 6 equals 8, then we know what's 20 plus 60? 80. And what's 2,000 plus 6,000? That's right, it's 8,000. Now, you can also subtract by adding. So this is something that we can think of as factor families. For example, if we have 8 minus 6, another way to think about that is think, what could I add to 6 to make 8? So you're kind of reversing the problem. You're thinking about it more in terms of a sort of algebraic expression. 6 plus what equals 8? It may be easier to solve some problems that way rather than thinking of them in terms of subtraction. This is a very simple example, but it can be used with numbers of all sizes. Now, another rule I want you to think about and keep in mind is the 10% rule. Now, if you're trying to find the percentage of something, the 10% rule can be really helpful because we know that 10% just means that we're going to move our decimal place one spot over to the left. So for example, if I want 10% of $10, I just move that decimal place over and I get $1. Same thing if it's $9. I move that decimal place over and now my number becomes 90 cents. 10% of $8 is 80 cents, 10% of $7 is 70 cents. So what about $6? That's right, 60 cents. And $5? 50 cents. So now what? If we have $34.60, it's still the same process, even though it may be a more complex number. We're just going to move that decimal place over, and we get $3.46. Same thing if we have 10% of $99.40, it's just $9.94. Now here's where it gets a little bit more tricky. What if I have $1,567.99? Well, I'm going to move my decimal place over, but then I end up with 799. Now, we all know that we can't have 799 cents. That doesn't make sense here, so we need to round that. We can only have those first two decimal places. And since the last number after that last decimal place is 9, it means we're going to have to round up. So we'd end up with $156.80. We take that 79 and round it up to the next number. Now for our last one, 10% of $2,300,456.92. Well, we'd end up with $230,045.69. You can see there that when we move the decimal place, we should have 692. And because that last number is 2, it's not high enough for us to need to round up. So we can just cut it off and round down to 69. All right, another rule that we'll use today is called the multiplication rule of 10, 100, or 1,000. All we have to do is add a decimal place and put in a 0. Now, for example, if I have 10 times 8, I see that I have 1 0 on the number 10. So that means I just need to add one decimal place to my other number, 8. So when I add a decimal place over, that turns the number into 80. I just fill that decimal place with a 0. Now, for another one, we have 100 times 24.5. Well, I can see that my decimal is before the 5, and there are 2 zeros on 100, which means I need to move 2 decimal places. So I'm going to move 1 over to include that 5, and then move 1 more and put a 0 in that place. So I get 2,450. Same with 1,000 times 3,456. If I see that I have 3 zeros, I need to find my decimal place, which would be after the 6, and I need to add 3 more places. So that's going to give me 3,456,000. And finally, if I have 10,000 times 220.204, well, I have 4 zeros on 10,000. So that means I'm going to need to move over 4 places. So I have 3 decimal spots there that I need to move over first. Let's go 1, 2, 3. That puts us past the 204. And then I need to do 1 more, and I can fill that in with a 0. So that gives me 2,202,040. Now, 5 times a number is another rule that we can use. So to find 5 times any number, it may be easier to think of it times 10 first, just like the rule we just practiced, and then cut that in half. So for example, 5 times 48, that's kind of a difficult one to do in your head. So you could instead do 10 times 48. Well, 10 has the 1 0, so I'm just going to add 1 decimal place to make that 480. And then I'm going to take half of that, and half of 480 is 240. So 5 times 48 is 240. Let's practice it with another one. What if we had 5 times 60? Well, what I could do is just do 10 times 60 first, which I know is very easy. I'll just add that extra decimal place and put in a 0, 600. And then if I did 600 divided by 2, I would get 300. So 5 times 60 is 300. Now, another trick here is to do 4 and 8 times a number. So we know that the number 2, if we double that, we get 4. And if we double 4, we get 8. So if we're doing 4 times the number, it's really just like doing times 2 times 2. And if we're doing 8 times the number, it's like doing times 2 times 2 times 2. So if you're doing some mental math, this is an easier way to break it down. Instead of 4 times 59, what I could do is 59 times 2, and then take the product of that, 118, and double it again to get 236. Same thing with the times 8. I could start by doubling 35 to get 70, doubling that to get 140, and then doubling that to get 280. So it's a way of breaking down these concepts to make them a little bit more manageable to do in your head. And lastly, our last skill for today will be to multiply in parts. So if you think about a number like 3 times 74, that can be a little bit more difficult than maybe breaking it down into smaller pieces. So instead of doing 3 times 74, I could do 3 times 70 and do 3 times 4 and just put them together. Now 3 times 70, I'm going to think about that like 3 times 7, which I know is 21, then add that 0 from the 70, so 210. And 3 times 4, I know is 12. So if I put those together, I get 222. Same thing for 6 times 218. I could even break it down into 3 parts. So I could do 6 times 200, 6 times 10, and 6 times 8. And when I put all those together, I get 1200 for the 6 times 200, 60 for the 6 times 10, and 48 for the 6 times 8. And altogether, I add those together to get 1308. Thank you so much for joining me today for this Math Roundtable recap. I hope you learned some new skills for your mental math and some things you can try and practice as you're working towards your test goals. You can check out more of our videos on this channel, and don't forget to subscribe so you get the latest updates. And if you like the video, leave a comment and a thumbs up. You can also check out the Helms Academy on Instagram and Facebook, or at our website at helmsacademy.org.